the El Nino of the century, months before it arrived.
Okay, well, we'll do the same on our side of the dividing line, and let's just pick Carter well.
Early in 1997, sophisticated instruments showed a blob of warm water in the western Pacific. It was moving eastward along the equator, preceded by predictions of doom. Television, newspapers, the World Wide Web, all were abuzz with warnings of storm, flood, fire, drought, famine, disease. El Nino became a water cooler topic, a climate phenomenon turned social phenomenon. In the United States, it was fashionable to blame it on El Nino, irrespective of what it was.
I believe that the 1997-98 El Nino is the El Nino of the users of El Nino information. Aside from good, solid information about El Nino, there were sites, El Nino Hype, El Nino No-Show, and things like that. So a lot of spoofing.
As the El Nino ran its course, the jokes fell flat. Charged with the energy of 1 billion Hiroshima bombs, El Nino scrambled weather patterns around the world. It killed an estimated 2,100 people and left at least $33 billion in property damage. Southeast Asia endured months of drought. Forest fires raged in Sumatra, Borneo, Malaysia, and Papua New Guinea. For weeks, much of the Indonesian archipelago was hidden by smoke. There was record flooding on South America's Pacific coast, in Asia's northeast, and in Central Europe. Hundreds died in Peru, Poland, the Czech Republic, and Korea. In the United States, mudslides and flash floods lashed communities from California to Mississippi. Storms pounded the Gulf Coast. Tornadoes ripped Florida. But it could have been worse, much worse. Although an event of greater power, in 97-98, death and destruction was less than for the previous great El Nino, the event of 1982-83. In 97-98, we were forewarned and forearmed by advances in the earth sciences. Disciplines like meteorology and oceanography. Crucial, too, were advances in technology. The deployment of powerful new eyes trained on the equatorial ocean.
The 1982-83 and the 1997-98 El Niños are bookends on a remarkable chapter in the history of climate research. 82-83 was neither predicted nor was it even observed till nearly at its peak. The 97-98 El Niño was tracked daily.
Since the early 80s, we've learned much about the climatic engine which produces El Nino. And we're learning how that engine interacts with the great machine of global climate. The study of El Nino is a step into the future. It's a stride towards meteorology's ultimate goal: accurate predictions of world weather. But there's a second El Nino story, which has emerged only recently. A tantalizing, elusive, sometimes bloodthirsty tale, whose details are obscured by time. It's the story of El Nino's role in some of the significant events of human history. The story of El Nino's past has gripped the imagination of Brian Fagan, professor of anthropology at the University of California, author of the book Flood, Famines, and Emperors. Until recently, scientists studying ancient cultures and those specializing in the tropical Pacific spoke to each other only rarely. Today, they work together because we've learned that El Nino has been disrupting global weather patterns since the close of the last ice age.
It's really only in the last 5 years that archaeologists certainly, and I think earth scientists, have really realized the amount that the one can tell the other. And it's only now that there's beginning to be this cautious dialogue between the two.
Much of this dialogue is focused on the region between the Andes Mountains and the equatorial Pacific, the coastal strip of northern Peru. This is one of the driest places on Earth. There's little or no rain for years on end. Yet the desert is broken by a procession of river valleys. Oases which rely on meltwater from the icy peaks to the west. Early in the 16th century, these valleys were strongholds of the Incas and were ruled from faraway Cusco, the mountain capital of the vast Incan Empire. The Incas were swept away by the Spaniard Pizarro and his conquistadors. Destroyed was Incan scholarship, and with it, much of the oral record of Peruvian history. In a region where writing was never developed, crucial details of the peoples and civilizations which predated the Incas were lost. But some things did endure. Tantalizing clues like the great platforms rising from the banks of the Lambayeque and Moche rivers. Vast mounds of mud bricks. Hundreds of millions of bricks. The largest adobe structures in the Americas. Two of the greatest face each other across an arid plain and were called by the Spaniards Huaca del Sol y de la Luna, the sacred places of the sun and the moon. Archaeologists are piecing together the story of the civilization which built these structures. They're finding that story in richly adorned tombs. In walls dedicated to savage gods. And in the elaborate ceremonies which inspired generations of craftsmen.
What we do as iconographers is to bring together all the moments of the story and reconstruct a sequence. And we have done that in great detail. We don't have writing, and we have no words to tell us what happened. I mean, nobody's telling us the story, but nevertheless we can reconstruct the whole sequence of events.
We call them the Moche, a civilization which straddled the coastal valleys of northern Peru 1,500 years ago.
The Moche was an extraordinary civilization, and I use the word extraordinary rather reluctantly because there were a lot of extraordinary societies in the past. If you reflect that Moche civilization flourished in the driest environment on Earth, and it flourished within the confines of a series of river valleys which were watered only by very, very rare rainfall and by mountain runoff from the Andes. And they managed to support tens of thousands of people by some of the most extraordinarily sophisticated and skillful irrigation anywhere in history. If you reflect on the wealth, it really is a truly amazing achievement.
We've learned that the Moche culture rose in the 1st century AD and flourished for more than 700 years. The heights of the sacred places were reserved for society's elite, a small group of families whose leaders are referred to as warrior priests. Theirs was a life of intense ritual. There were ceremonies to appease the gods, and ceremonies to demonstrate the power of men and women who believed themselves to be gods. The most important of these ceremonies was performed at the Huaca de la Luna. It included combat, human sacrifice, and the ritual consumption of human blood.
Groups of people get together completely armed in all the military gears and fight against each other. Nobody dies in the field, but instead people are taken captives. And they lose their dignity by losing their clothing and their headdresses. On top of the Huaca de la Luna, we have found the bodies of these people, the real bodies, the corpses, with many times the bones have scratches and marks of cuts that have been inflicted in the bodies. And it is very clear that they were trying to get the blood out of the bodies. They were trying to get the fluid of life out of these individuals. This is not only a ritual discourse of death, but it's a ritual discourse of power. I mean, they are representing something that is only meant to be done by the elite.
In the middle of the 8th century, something went wrong, catastrophically wrong. Virtually overnight, the Moche culture collapsed. Its disappearance has baffled generations of archaeologists. A 1,000 years later, the mid-19th century, and another mystery rocks the Peruvian coast. The deaths of millions of seabirds. Although the coastal strip is arid, prospects for life are very different offshore. A phenomenon called upwelling, cool, nutrient-rich water rising from the depths, makes the ocean off Peru the equivalent of a tropical rainforest. It teems with anchovies and other fish, which support many millions of gulls, cormorants, and pelicans. They nest on cliffs and on small coastal islands. The tale of El Nino begins at the bottom, with the droppings which bury nesting sites to depths of up to 30 meters.
It all began with bird guano. Bird guano was an enormous industry in 19th century Peru. Peruvian bird guano is the finest natural nitrogen-rich fertilizer in the world. They exported to Europe and North America some staggering sum, something like $200 million in 19th century dollars worth of guano.
The industry was so important that any threat to feces production was viewed with the utmost seriousness. Such a threat emerged in the late 1860s. The anchovy shoals disappeared, dooming to starvation many of the seabirds upon which the guano industry depended. Although fish and bird populations had recovered within a few seasons, local scientists puzzled over the mystery. At the time, few understood the close relationships between animals and their environments.
And it wasn't until the late 1880s and early 1890s that these scientists talked to the fishermen, and the fishermen said, it is El Nino, the Christmas child. A warm current from the north which flows down the coast, removes the cold water which nourishes the anchovies, and the birds go with the anchovies or starve. And we always call this El Nino because it comes at Christmas, the Christmas child. And in 1891, a Peruvian scientist announced this to an international conference, and El Nino entered the scientific literature. But it entered it as a local phenomenon.
The occasional warm northern current, which so disrupted local fisheries, coincided with the rarest of events in the coastal desert: torrential rain. As the century turned, the strange current came once more, and with it, storm and flood. In 1899, as in 1998, entire communities were swept away. It prompted the gentleman scientists of Peru to announce that El Nino exerted a very great influence over their part of the world. None suspected its true nature, its tremendous power, its phenomenal reach. half a world away, the last months of the 19th century were consumed by horrors far greater than Peru's rivers of mud. The twin catastrophes of drought and hunger.
There were a series of truly devastating famines in India caused by the failure of the Indian monsoon. Because farmers depend on the annual rain brought by the monsoon. Millions, and I mean millions of people died because there was not the infrastructure in India, created by the colonial authorities, to bring famine relief. And in 1904, the Indian Raj, the Indian government, appointed a director of meteorology called Gilbert Walker to try and forecast monsoons. In the finest British fashion, they appointed Gilbert Walker, who had absolutely no meteorological experience at all.
What Gilbert Walker lacked in meteorology, he made up for with dogged persistence. Walker was a statistician, a numbers man, and he applied those skills to the intricacies of the monsoon, the period from June to October, in which falls most of India's annual rains.
Sir Gilbert Walker hired lots of what now we wouldn't call them that, but computers. He hired people who sat there and did the math. He just correlated everything with everything, trying to find out what gave him the best clue.
This was Walker's great breakthrough. His was the first serious attempt to forecast local events by studying distant weather patterns. Walker discovered that monsoon failures in India often coincided with aberrant weather elsewhere. Flooding rains on the Pacific coast of the Americas. Droughts in Egypt, Africa, and Australia. Unusually mild winters in Canada and New England. With his team of number-crunching clerks, Walker was searching for strategic points of world weather. Atmospheric systems with wide-ranging influence, even global influence.
Because he was convinced that there was a link between monsoons and pressure changes over enormous distances. And in 1921, he identified a seesaw-like oscillation of pressure in the Southwest Pacific, which measured basically the pressure difference between Darwin, Australia, and Tahiti, and named it the Southern Oscillation.
Walker's findings emerged from thousands of barometer readings recorded over decades. Most of the time, atmospheric pressure at Darwin was relatively low, and at Tahiti, relatively high. But every 3 to 7 years, this pressure profile temporarily reversed. Walker claimed this oscillation of pressure was a phenomenon of enormous importance to world weather, a claim for which he was ridiculed by his peers. Walker could not prove his theories. His attempts to predict the Indian monsoon came to nothing. And he failed to connect what he'd learned about the atmosphere of the Pacific's west with the strange El Nino current of the ocean's east. Walker went to his grave in 1959, his ideas challenged or ignored. But within a decade, vindication. In the late 1960s, a Norwegian meteorologist, Jacob Bjerknes, bridged the Pacific Divide. He combined East and West, ocean and atmosphere, El Nino and Southern Oscillation.
The El Nino in the eastern part of the basin and the Southern Oscillation are put together to say that El Nino is really a basin-wide phenomenon. And it wasn't until after that that scientists started to take a closer interest. We've really only known about the phenomenon as a basin-wide or global impact phenomenon since the mid-1970s. That's 25 years or so. So there's a lot to learn, but there's a lot we know.
In normal years, there's a pool of warm surface water in the western Pacific, covering an area the size of the continental United States. This water is a vast reservoir of heat energy, some of which is transferred to the atmosphere. Hot, saturated air rises and is pushed by pressure differences to the east. When it arrives at the shores of South America, the air has become dry and cool. It descends to the surface and turns west again, forming the equatorial trade winds. Cool, too, is the ocean of the eastern Pacific, because the trade winds tend to push surface water away from the South American coastline. It's replaced from below by cold, nutrient-rich water, the upwelling phenomenon which supports the explosion of life off coastal Peru. During El Nino conditions, the equatorial Pacific is turned on its head. The westward flowing trade winds weaken, and sometimes they reverse. This allows the vast pool of warm water in the west to migrate to the central and eastern Pacific. Upwelling continues along the Peruvian coast, but the water coming to the surface is warmer and poorer in life-supporting nutrients. In one way, however, the waters are rich. The energy they contain triggers massive cloud formation, the monster El Nino storms which ravage the coastal desert. Typically, El Ninos last from 12 to 18 months. Eventually, the trade winds regain their strength, returning conditions to normal, and occasionally, conditions more pronounced than normal. These anti-El Nino periods have been dubbed La Niña events. La Niña meaning the girl child.
La Niña is viewed as normal, or an extreme case of normal. In some locations, normal heavy rains mean you're walking in the streets with water up to your knees. With a La Niña, an extreme case of normal, in quotes, maybe the water's up to your chest. You kind of expect it to be flooding, but you don't expect it to be severe flooding.
With phenomena like El Nino, generalizations can be dangerous because every Christmas child has unique characteristics. This we learned late in 1982 with the onset of an unusually powerful event. An El Nino which humbled an overconfident science community.
There was a meeting as late as October of 1982 in Princeton, New Jersey, where all the top forecasters were together, the researchers of El Nino. And at that moment in October, they said there would be no El Nino because they were enamored by one scientist's views about precursors. There must be these four conditions, and one or two of the four conditions was not present. So therefore, there can't be an El Nino.
It caught the community by surprise, and this was a shock. Our observing system capabilities were very primitive at the time. That El Nino was neither predicted nor was it even observed until it was nearly at its peak.
El Nino unexpected, the world unprepared, and as it turned out, at the worst possible time. The 82-83 event will long be remembered for the unusual severity of its teleconnections. the term used by meteorologists for the idea championed a century ago by Gilbert Walker.
A phenomenon in one part of the world affecting weather or climate in another part of the world. So, for example, El Nino, we know, is characterized by warming of the equatorial Pacific Ocean every few years. But it's also characterized by warmer and drier winters in the Pacific Northwest, wetter and colder winters along the Gulf Coast states of the U.S., rainfalls, heavy rains in western South America, drought in Australia and Indonesia. Those are teleconnection patterns that result from warm sea surface temperatures in the eastern and central equatorial Pacific.
But El Nino's teleconnections, the phenomenon's tentacles, reach far beyond the borders of the Pacific Ocean. In 1982-83, southern and sub-Saharan Africa were in deep drought, famine-producing drought. And on the Indian subcontinent, the life-giving monsoon failed. These distant teleconnections are some of the most disastrous and the most difficult to predict.
There are other things in the climate system that can affect weather variability, so that the further you get from the tropical Pacific, the weaker the link becomes between El Nino and weather in different parts of the world.
What was clear in the aftermath of 1982-83 was the need for revolution in the science of ENSO, the El Nino Southern Oscillation, a revolution in monitoring and forecasting. One solution came from the United States, the Tropical Atmosphere Ocean Project, the deployment of buoys heavy with sensors across the equatorial Pacific.
One of the key elements of what we call the ENSO observing system is this network, 70 deep ocean moored buoys that spans the width of the tropical Pacific from near the coast of South America to near the coast of New Guinea. Each one of these buoys is anchored to the ocean floor with old railroad car wheels. There's about 3 or 4 miles of nylon and steel rope. And on this rope, in the upper third of a mile or so, we have 10 temperature sensors. And then at the surface, we have a little donut-shaped float that has on it a tower with instruments to measure air temperature, winds, and some other atmospheric variables. These buoys return data from the tropical Pacific about 6 times per day. So we can essentially track the evolution of the climate system in this part of the world on an hour-by-hour, day-by-day basis.
The data beamed to McFadden and his team in Seattle is routed immediately to the World Wide Web and a worldwide audience of researchers. Available too is data collected by satellite, remote sensing platforms which monitor every aspect of tropical atmosphere and ocean. Researchers look for abnormal wind patterns and for changes in sea surface temperature, signs of a new El Nino up to 6 months ahead of destructive side effects.
If you can observe the evolution of the climate system in the tropical Pacific with the kind of clarity and precision that we can with this buoy array and with also other kinds of climate measurement techniques that we have today, once you see unusual temperatures develop, we know historically that they will persist for 3 to 6 months into the future.
Because El Nino develops slowly, observation is the best way to forecast in the midterm. But for long-term forecasts, for warnings years in advance of El Ninos, other tools are needed. Many researchers are putting their faith in climate models. in cyber oceans and cyber atmospheres. El Nino after El Nino, born, living, dying in the minds of supercomputers. The models are fed real-world data from the array of buoys and from Earth-observing satellites. The supercomputers run this data into the future, calculating climate months, even years in advance, based on scientists' assumptions about how El Nino works. Those assumptions and the systems keeping watch on the real world were tested severely, much sooner than the science community expected. Researchers had dubbed the 82-83 event the El Nino of the century, in the belief that another super El Nino was decades away. Once again, science got it wrong, because the event of 1997-98 was even more powerful. What science got right was El Nino surveillance.
We were much better off in 97-98 with regard to preparedness because we were able to observe the 97-98 El Nino, and we were able to track the El Nino as it evolved essentially day by day. This meant that individuals, companies, governments, both state governments and national governments, could take action that would mitigate against some of the more adverse aspects. For example, in Southern California, coastal communities were mobilized to build beach berms, protecting against the high waves that they expected from storminess. This kind of preparedness was undertaken on a scale never before possible because we didn't have the lead time information that we had before 97-98.
Success for the watchers, but according to Mickey Glantz, failure for the cyber forecasters.
The monitoring of El Nino has greatly improved since 1982-83. I would argue also that the forecasting of El Nino has not greatly improved. 15 major forecasting activities for the 1997-98 event failed to forecast the onset of that El Nino. My personal feeling is that every El Nino has surprised us. The mystery of El Nino is bigger than we thought.
One mystery of El Nino was solved only recently: the phenomenon's age. And once again, El Nino surprised us. The answer was drawn from ice, wood, and mud. Ice cores from glaciers, which hold and preserve the chemistry of ancient atmospheres. The annual growth rings of trees, clues to rainfall and temperature changes over hundreds, even thousands of years. And sediments from the beds of Peruvian lakes, in which are recorded the furies of El Nino storms. From these, we have learned that the Christmas child, which came to the attention of science only a century ago, has been causing chaos for more than 15,000 years. Most scientists had thought it a more recent climate event. Building on the breakthroughs of Earth science, archaeologists are revisiting the mysteries of peoples like the Moche. It's thought that the ultimate power wielded by the Moche elite, society's living gods, came at a price: ultimate responsibility. It was the job of the human deities, the warrior priests, to regulate the forces of nature.
When you assume the functions of a deity, you have to provide what the deities are supposed to provide, and that is the welfare of society. I mean, you are responsible for everything good, but you're also responsible for everything bad.
It's now clear that for the Moche, nature's most dangerous tantrum was El Nino. Flooding rains would have damaged, even destroyed the intricate system of irrigation canals, reducing significantly the Moche harvest. Warm El Nino waters would have cut catches of fish. To the Moche, El Nino meant famine, and defeating it was the job of the elite. From the excavations at the Huaca de la Luna, evidence is emerging that El Niños coincided with a frenzy of human sacrifice.
There are layers of mud that are associated with Nino rains, within which they are finding 50, 20, 70 people that were sacrificed for the purpose of a ritual that happened in conjunction with that. Now, we can interpret that all these people were ritually killed to appease the gods, a ritual that was augmented in size and complexity because of what was going on in terms of rain. We're not sure of that.
The relationship between the Moche and El Nino becomes even more intriguing when account is taken of ancient weather reports extracted from glacial ice in the Andes. Beginning around 750 AD, coastal Peru endured 20 years of savage drought, punctuated by powerful El Ninos. This is the time of the Moche's mysterious disappearance.
If a society like the Moche was hit by an El Nino when it was healthy and strong, I guess it would have survived. But when you have a number of things happening at the same time, you have a bad year in terms of El Nino, you have a weakened elite. I think that they were weakened because they were overspending in rituals, in human sacrifices, in building temples and things like were meant to be means and not ends. On top of that, they had neighbors that were not that friendly or were in a process of expansion. It's not that the El Nino destroyed this society, and I don't think that El Nino or weather in general can destroy any society. No. It is that if these events happen in conjunction with a general weakening of society, then it can be devastating.
To the Moche, El Nino was a knockout blow. And there's evidence the phenomenon played a similar role in the destruction of other civilizations. El Nino has been linked to the failure of monsoon rains in the highlands of Ethiopia. Rains which feed the annual flood of the Nile. The fall of Egypt's Old Kingdom, the kingdom which built the Great Pyramids, coincided with a series of terrible droughts.
How did the ancient Egyptians cope with these enormous variations in the flood? We have this view that Egypt prospered for 3,000 years because every year the flood came down and watered the field. It's lovely stuff. It's sort of, you find it in all the school books. This, in fact, is not true. The Nile was very unpredictable. And during the Old Kingdom, the time of the pyramids, it actually had a whole series of very good floods. And then suddenly in 2181 BC, it fell apart. And it fell apart with a capital F. And the result was that the pharaohs who had considered themselves and preached that they were infallible found themselves in trouble because people said, "You're infallible, where's the flood?"
Professor Fagan believes that the crises of climate faced by the ancients hold important lessons for the future. Science has given us the means to understand and to track the Christmas child. But will that be enough in the uncertain decades to come? Some scientists suggest that in a world warmed by greenhouse gases, El Niños will become more frequent, more powerful. Others point to the influence of ocean atmosphere systems, of which we as yet know very little. Systems which evolve over decades, even centuries.
It's likely that all these phenomena are interacting in very complicated ways. And so unraveling these mysteries of how the climate system works is something that's going to be occupying us for generations to come.
In some parts of the world, crisis could be more immediate. Crises triggered by population pressures. Too many people. Environments too fragile.
What's happening is that people are moving into margins. They're increasingly putting themselves at risk. We're going to hear a lot more about droughts and floods than we've heard in the past. And that's not necessarily because the climate's changing, although it could be, but it's not necessarily because of that, but it's because the expanding populations are moving into marginal areas.
Every society, complex or simple, that developed in the world, has been destroyed at some point. We can be destroyed like any other society before us.
Some futurologists are talking about significant crash of global population in 2 or 3 centuries. And by significant, they mean 10, 20% or more. Don't tell me we're not vulnerable. And El Nino is part of that equation. We're more vulnerable than ever in history.
There was record flooding on South America's Pacific coast, in Asia's northeast, and in Central Europe. Hundreds died in Peru, Poland, the Czech Republic, and Korea. In the United States, mudslides and flash floods lashed communities from California to Mississippi. Storms pounded the Gulf Coast. Tornadoes ripped Florida. But it could have been worse, much worse. Although an event of greater power, in 97-98, death and destruction was less than for the previous great El Nino, the event of 1982-83. In 97-98, the El Nino of the century, months before it arrived.
Okay, well, we'll do the same on our side of the dividing line, and let's just hit Chicago well.
Early in 1997, sophisticated instruments showed a blob of warm water in the western Pacific. It was moving eastward along the equator, preceded by predictions of doom. Television, newspapers, the World Wide Web, all were abuzz with warnings of storm, flood, fire, drought, famine, disease. El Nino became a water cooler topic, a climate phenomenon turned social phenomenon. In the United States, it was fashionable to blame it on El Nino, irrespective of what it was.
I believe that the 1997-98 El Nino is the El Nino of the users of El Nino information.
We were forewarned and forearmed by advances in the earth sciences. Disciplines like meteorology and oceanography. Crucial, too, were advances in technology. The deployment of powerful new eyes trained on the equatorial ocean.
The 1982-83 and the 1997-98 El Ninos are bookends on a remarkable chapter in the history of climate research. 82-83 was neither predicted nor was it even observed till nearly at its peak. The 97-98 El Nino was tracked daily.
Since the early 80s, we've learned much about the climatic engine which produces El Nino. And we're learning how that engine interacts with the great machine of global climate. The study of El Nino is a step into the future. It's a stride towards meteorology's ultimate goal: accurate predictions of world weather. But there's a second El Nino story, which has emerged only recently. A tantalizing, elusive, sometimes bloodthirsty tale, whose details are obscured by time. It's the story of El Nino's role in some of the significant events of human history. The story of El Nino's past has gripped the imagination of Brian Fagan, professor of anthropology at the University of California, author of the book Flood, Famines, and Emperors. Until recently, scientists studying ancient cultures and those specializing in the tropical Pacific spoke to each other only rarely. Today, they work together because we've learned that El Nino has been disrupting global weather patterns since the close of the last ice age.
It's really only in the last 5 years that archaeologists certainly, and I think earth scientists, have really realized the amount that the one can tell the other. And it's only now
Aside from good, solid information about El Nino, there were sites, El Nino hype, El Nino no-show, and things like that. So a lot of spoofing.
As the El Nino ran its course, the jokes fell flat. Charged with the energy of 1 billion Hiroshima bombs, El Nino scrambled weather patterns around the world. It killed an estimated 2,100 people and left at least $33 billion in property damage. Southeast Asia endured months of drought. Forest fires raged in Sumatra, Borneo, Malaysia, and Papua New Guinea. For weeks, much of the Indonesian archipelago was hidden by smoke.